everyone. Welcome to our virtual science club meeting.
Today we're going to cook dinner by solar energy and sun.
Okay,
Cooker.
Good job. So we made a solar cooker. And solar cookers are really easy to construct. You basically just need to come up with a way to capture heat and then reflect it and focus it all on one place. So the sunlight's going to come in through this little hole right here, and it's also going to get reflected down into here, and then any heat that comes in gets focused on our plate. Yes, you may. So right now on our bricks out here, it's a hot August day. The bricks have a temperature of 109. That's a hot, hot day. So we are going to set up our cooker on the hottest part that we could find. Now the initial temperature of our hot dogs on the inside, let's see, our hot dogs right now, because they've been sitting out here, let's give it a second to come to thermal equilibrium. We pulled these hot dogs straight out of the fridge, waiting patiently, waiting patiently, waiting patiently. It's in the 60s. We'll just go with that because we pulled them out of the fridge and they've been sitting on this hot, hot, hot wall for a few minutes. So it's in the 60s initially. So let's take a sample. Let's put our hot dogs in. Put them in our solar cooker here.
Mama, can I help?
After they're cooked, you can eat one.
After they cook, I can eat one?
That's right. So we're going to put 1, 2, 3, 4, 5. We've got 5 of them in there. Now we close the lid. Actually, we're going to put our temperature probe in there so that we can still know what the temperature is inside.
Yes, and always go, and it just went up to 70.
So that's the temperature that it's inside right now. We're going to come back every few minutes and take a temperature reading. So see you in a few minutes. Just for comparison, because we scientists like to have a good control group, we're setting these hot dogs directly on the bricks to see which will cook faster, the ones directly on the bricks, and their original temperature of the bricks was 109, or the hot dogs in the solar cooker. We'll find out. All right, so it's been about 15 minutes, and the temperature inside our hot dogs is currently 90 for the ones in the cooker. And had the pair of scissors there just to keep it from blowing open, keep bugs out. Let's see what the temperature is inside the ones that are not in the cooker. So not that much of a difference actually. The ones that are in the cooker were at 90 and the ones that are just sitting on the bricks are at 86. Pretty interesting. We'll be back in 15 minutes. All right, scientists, we're back. It's been another 15 minutes. The temperature inside the hot dogs in the solar cooker is now 100 degrees Fahrenheit. Now, let's take the temperature of the hot dogs that have not been in the cooker. What do you predict? Do you think it'll be hotter or cooler?
Probably a bit hotter because it's been hotter out here.
Oh, okay, that's a good prediction.
Probably cooler.
So we got one of each. Let's see what we have. The temperature inside the hot dogs that are not in the cooker is 93. So what does that tell us about the cooker? Does that make the temperature?
So it's like
It traps the heat.
It traps the heat. That's right. So the light comes in. And remember, what did we learn about shiny surfaces? They cause the heat to bounce around, reflect. That's right. Good job.
To bounce off.
So all that heat bounces around and just stays inside and doesn't escape. So that's why the temperature is raising faster in our cooker. All right, we'll be back in another 15 minutes. So I think we've come to the end of our experiment. We've got to our max temperature. We got a couple ants on some of these, so that one's going to have to be thrown out. That's why we're calling it a day on the solar cooker. We got a few ants who've taken interest in our dinner here. But we achieved a maximum temperature just over 100. So basically we came to thermal equilibrium with the bricks themselves, which is kind of interesting. I was expecting a little bit of a higher temp. What do you think we should do at a different time when we try this experiment again? What's something we can do when we try it again? Do it on a hotter day?
So that all the ants will get out and won't be out in the sun.
So don't you think that means we would do it on a cooler day?
Maybe.
Because what if we did it on a cooler day and we saw how much heat was trapped by the solar cooker on a day when it already wasn't really hot? Do you think that would work?
Maybe.
So maybe that'll be an experiment for a future Cooking with Science Day. Thanks for watching. Bye.
Bye.